Welcome to the Quasarea channel. Today we will go to one of the most mysterious and creepy places in the universe, where there is almost nothing. We'll talk about the Boötes Void, a gigantic cosmic void that forces us to rethink the very nature of the cosmos. Imagine a region of space 330 million light years in diameter with virtually no galaxies. It's not just an empty place. It's such a vast void that light would fly through it for 330 million years. For comparison, our Milky Way galaxy has a diameter of only 100,000 light years. The Boötes Void is 3,300 times larger than our home galaxy. This cosmic void was discovered in 1980 by astronomer Robert Kirchner and his colleagues. They were conducting a survey of the distribution of galaxies in the constellation Boötes and stumbled upon something incredible, a giant region where there are almost no galaxies. While there are tens of thousands of galaxies in the ordinary regions of the universe, there are only about 60 galaxies in the void of Boötes. Imagine that you are flying through this void at the speed of light. There is endless darkness around you. No galaxies, no stars, no light. Just you and the absolute blackness of space. And so, for 330 million years of continuous flight, this is such a huge distance that the human mind can hardly comprehend it. But what is a void anyway? This is not just empty space in the usual sense. Voids are a natural part of the large-scale structure of the universe. If we look at the distribution of galaxies in space, we can see that they form a kind of cosmic web. Galaxies gather into filaments and walls surrounding huge empty areas, voids. The Boötes Void is one of the largest voids known to us, but it is not the only one. There are other similar structures in the universe, but it is this void that is striking in its scale. When astronomers first discovered it, it was a real shock. No one expected to find such a large region with virtually no galaxies. Why do such voids form? It's all about how the structure of the universe was formed after the Big Bang. In the early universe, there were small fluctuations in the density of matter. Regions with a slightly higher density attracted even more matter with their gravity, becoming denser. Areas with lower density, on the contrary, lost matter, becoming even more empty. Over time, this process led to the formation of the structure we see today, dense clusters of galaxies and huge voids between them. But the void of Boötes is not entirely empty. There are still about 60 galaxies there, although this is negligible for such a volume of space. These galaxies are like lonely islands in an endless ocean of emptiness. If an intelligent civilization existed on a planet in one of these galaxies, their night sky would look completely different from ours. Almost no neighboring galaxies, almost no distant points of light, only endless darkness. Interestingly, there may be a lot of dark matter and dark energy inside the voids, although there is very little ordinary matter there. Dark matter is a mysterious substance that we can't see directly, but that makes up about 85% of all matter in the universe. Dark energy is an even more mysterious force that causes the universe to expand faster and faster. Voids expand over time. As the universe expands, the voids become even larger, and the clusters of galaxies become even denser. The Boötes Void is now even larger than it was millions and billions of years ago, and will continue to grow. The existence of huge structures like the Boötes Void gives us important information about the nature of the universe. By studying the distribution of voids and galaxy clusters, Astronomers can test cosmological models, refine cosmological values, and better understand how the universe evolved. There is something almost eerie about the existence of such gigantic voids. They remind us of how vast and largely empty our universe is. The distances between galaxies already seem incomprehensible, but voids are a whole other level. These are the areas where emptiness is brought to the absolute. If you imagine a journey through the void of Boötes, it would be the loneliest journey imaginable. Even if you had a telescope and were somewhere in the center of this void, you would have to look hundreds of millions of light years away to see any galaxy. Nearby star systems would be so far away that they would appear to be just faint points of light at the edge of visibility. For a civilization that developed in one of those few galaxies inside the void, cosmology would be a completely different science. For a long time, they could have believed that their galaxy was the only one in the universe. Only with the development of powerful telescopes would they be able to detect distant, barely discernible nebulae at the edges of their observable universe. Imagine how shocking it would be for them to discover that beyond their void, there are regions of space where galaxies literally crowd together, forming huge clusters and superclusters. The Boötes Void is located approximately 700 million light years away in the direction of the constellation Boötes. This means that the light we see from the borders of this void began its journey 700 million years ago, when complex multicellular life was just beginning to emerge on Earth. We look into the past, observing the structure. But the void of Boötes is not the largest known void. There is an even larger structure called the giant void in the constellation Eridanus, or the cold spot, which can be up to 1 billion light years in diameter. This makes us wonder, how many more such structures exist in the universe? How many gigantic voids lurk in the unknown depths of space? The study of voids helps us understand fundamental questions about the nature of the universe. For example, the distribution of voids is sensitive to the properties of dark energy. If dark energy changes over time or has certain properties, it will affect how voids grow and evolve. Therefore, astronomers carefully map voids, measure their sizes, and study their evolution. There are also theories that there may be special conditions inside the voids for the formation of certain types of galaxies. Those rare galaxies that are in voids often have unusual properties. They may be more isolated, which affects their evolution, without close neighbors to collide with or interact with gravitationally. These galaxies evolve differently. It is also interesting to think about the future of void Boötes. As the dark, energy-driven universe expands, the voids will get bigger and bigger. Galaxies at its boundaries will move away from each other, and those few galaxies inside the void will become even more isolated. In billions of years, this void may become even more empty, even more huge. In the distant future, trillions of years from now, when the stars begin to fade away and the universe is plunged into darkness, the voids will become completely empty and cold regions. No light, no heat, no movement. Only infinite emptiness, stretching for unimaginable distances. Boötes Void also poses philosophical questions to us. What does the existence of such huge, empty spaces mean? The universe didn't have to create such structures, but they do. It's part of the natural order of things, the result of gravity and the expansion of space over billions of years. There is something poetic about the contrast between densely packed galaxy clusters and huge voids. The universe is not a homogeneous distribution of matter, but a complex structure of filaments, walls, and voids. This is cosmic foam, where matter collects at the boundaries of bubbles and inside the bubbles. Almost nothing. For astronomers, the void Boötes is a laboratory for studying the large-scale structure of the universe. Every new observation, every new galaxy discovered inside or at the edge of the void adds a piece to the puzzle of our understanding of the cosmos. Modern sky surveys, such as the Sloan Digital Sky Survey, map millions of galaxies and allow us to see these giant structures in all their glory. Technology is evolving, and our ability to learn voids is improving. New telescopes, more sensitive detectors, more powerful data processing computers all allow us to delve deeper into the mysteries of these cosmic voids. Perhaps in the future we will discover even more amazing properties of voids, which we do not even suspect now. The Boötes Void reminds us of the scale of the universe. We live on a tiny planet orbiting an ordinary star in an ordinary galaxy that lies in a relatively dense region of space. But if we go far enough, we see that most of the universe is emptiness. Matter, stars, galaxies, everything we know and love occupies only a small part of outer space. And this emptiness is not static. Voids actively affect the motion of galaxies around them. Galaxies at void boundaries experience gravitational repulsion from these empty regions, as if the void is pushing them away. This isn't really repulsion. Rather, galaxies are attracted to dense clumps of matter at the edges of the voids, creating the illusion that the void itself is repelling them. This process is called gravitational flow, and it forms the large-scale structure of the universe. If we could see the universe from the outside, on a scale of billions of light years, we would see an amazing picture. Galaxies form filaments and sheets that surround huge spherical voids. It is like soap foam or a sponge. Matter is concentrated in the walls, and inside there is emptiness. The void of Boötes is one such empty cell in this space sponge. Surprisingly, despite the fact that voids appear empty, they play a critical role in the evolution of the universe. Without voids, there would be no such rich structure of galaxies. The contrast between dense and empty regions is what creates the variety of cosmic structures we observe. Voids are not just the absence of something, they are active participants in cosmic evolution. It's interesting to think about how the discovery of the Boötes Void has changed our understanding of the universe. Before its discovery in 1980, astronomers knew that galaxies were unevenly distributed, but the scale of this unevenness was shocking. A void 330 million light-years in diameter seemed too large to fit into the cosmological models that existed at the time. This discovery has forced scientists to rethink many theories about the formation of the structure of the universe. Since then, other giant voids have been discovered, and we now know that this is a normal part of the cosmos. But the Boötes Void remains one of the most studied and most impressive. Its size, shape, and location make it an ideal object for research. Inside voids, the rate of expansion of space can be slightly different from the average rate of expansion of the universe. Because there is less matter, the gravitational slowdown in expansion is weaker, and the void can expand a little faster. This is a subtle effect, but it has implications for understanding the dynamics of the universe as a whole. Imagine an astronomer from the galaxy inside the Boötes Void trying to measure the expansion rate of the universe. Their measurements might be slightly different from ours because they're in a different environment. This shows how important it is to take into account local conditions when studying the global properties of the cosmos. There are also suggestions that the voids may affect the cosmic microwave background radiation, the CMB radiation from the Big Bang. As photons of this radiation pass through the voids, they can lose or gain energy due to the integrated Sachs-Wolf effect. This creates faint cold or hot spots on a microwave background map. By studying these spots, astronomers can learn more about the voids that lie between us and the surface of the last scattering. The Boötes Void also makes us think about the probability of life in the universe. If most of the cosmos is a void, then most of the universe is uninhabitable simply because there are no stars or planets. Life can only exist in areas where there are galaxies, stars, and planetary systems. This means that the habitable universe is just a thin web in a vast ocean of emptiness. But even in voids, there can theoretically be life. The few galaxies that are there can contain stars and planets. Life there would be incredibly isolated. No neighboring civilizations in nearby galaxies. No travel between galaxies. Only loneliness in the midst of endless emptiness. Philosophically, Boötes Void reminds us that the universe was not made for us. It's not a cozy place filled with galaxies and stars. Most of the cosmos is a cold, dark, empty abyss. We live in an exceptionally favorable place in a relatively dense region of space where there are many stars and galaxies around us. When we look at the night sky, we see thousands of stars. But this is a deceptive impression. These stars are only our closest neighbors in our galaxy. If we could fly far enough into the void of Boötes, our night sky would be almost empty. Maybe a few faint points of light, and that's it. That would be a completely different perspective on the universe. The study of the Boötes Void is also related to the search for dark matter. Scientists believe that the voids are not completely free of dark matter. It's just less of it than in other regions. Understanding the distribution of dark matter in voids could help us unravel the nature of this mysterious substance. Perhaps by observing the motion of those few galaxies in the voids, we could detect the subtle effects of dark matter. There are also ideas that voids may be connected to dark energy in a special way. Some alternative theories of gravity suggest that gravity may behave differently in regions of very low matter density. Voids are the perfect place to test such theories. If we find that the voids don't expand in the way that general relativity predicts, it could point to new physics. Modern cosmological simulations attempt to recreate the formation of structures, such as the Boötes Void. Scientists are using powerful supercomputers to simulate the evolution of the universe from the Big Bang to the present day. In these simulations, they lay down the initial conditions, tiny density fluctuations in the early universe, and watch as gravity turns them into voids and clusters of galaxies. Surprisingly, these simulations do produce structures similar to the Boötes Voids, which confirms our understanding of cosmology. However, there are also mysteries. Some voids appear to be too big for their age. That is, according to our models, they haven't had enough time to grow to that size since the Big Bang. This could indicate that we don't understand something about cosmology, or that our measurements aren't entirely accurate. The Boötes Void is fortunately not one of these anomalously large structures, but studying it is still important for calibrating our models. It is also interesting how voids affect our perception of distances in the universe. When light from distant galaxies passes through the void, it travels through a region with a lower density of matter. This may have a slight effect on the redshift of light, an effect by which astronomers determine the distances to galaxies. Although this effect is small, it needs to be taken into account in accurate cosmological measurements. There is something almost mystical about the idea of traveling through absolute emptiness. If we had a spacecraft capable of traveling at the speed of light and we went through the void of Boötes, this journey would take 330 million years. During this time, an entire civilization could evolve and disappear on Earth. The continents would shift, the oceans would change their shapes, and the stars in the sky would take up new positions. And all the while, you'd be flying through the darkness, seeing almost nothing. For science fiction, voids are of particular interest. These are ideal places to hide from the rest of the universe. A civilization wishing to avoid contact with other intelligent species could have settled in one of the galaxies inside the void. There they would be relatively safe, protected by vast distances from curious neighbors. Of course, this is pure speculation, but it shows how voids capture our imagination. In terms of energy, voids are regions with minimal gravitational potential. If you could somehow extract energy from gravitational fields, voids would be the least promising places to do so. There is simply not enough matter to create significant gravitational fields. This is another way of thinking of voids as gravitational valleys in the landscape of the universe. Studying the Boötes Void also helps us understand the process of galaxy formation. Galaxies and voids formed under conditions of low density and weak gravitational interaction with their neighbors. This means that they may have evolved more slowly and calmly than galaxies in dense clusters, where frequent collisions and mergers are common. By studying these isolated galaxies, we can understand what the normal evolution of a galaxy looks like without external perturbations. There's also the question of how galaxies get into voids. Some of them may have formed there originally, from rare clumps of matter in this area. Others may have been ejected there by gravitational interactions with more massive galaxies. Imagine a galaxy that was once part of a cluster, but was ejected by a gravitational slingshot and is now drifting alone through the void. It would be an exiled galaxy, doomed to eternal loneliness. Void temperature is another interesting aspect. There is very rarefied gas in intergalactic space that can be heated to millions of degrees by shock waves from supernova explosions and galactic activity. But there is even less of this gas in the voids, and it is colder. These are the coldest regions of the universe in terms of the temperature of the intergalactic medium, approaching the absolute zero of the cosmic microwave background, minus 270 degrees Celsius. The Boötes Void also plays a role in understanding the large-scale flows of matter in the universe. Galaxies don't just move away from each other due to the expansion of the universe. They also have so-called peculiar velocities caused by the gravitational pull of surrounding matter. By studying these streams around the voids, astronomers can map the distribution of dark matter in space. For future generations of astronomers, the Boötes Void will remain an important object of study. Each new generation of telescopes brings new discoveries. The James Webb Space Telescope, launched in 2021, allows us to see more distant and fainter galaxies. It is possible that it will discover more galaxies in the Boötes Void, which were too faint for previous instruments. Or perhaps it will confirm that the void is indeed as empty as we think it is. There are also plans for future sky surveys that will map billions of galaxies with unprecedented accuracy. These surveys will allow us to see the three-dimensional structure of the universe in detail that was previously impossible. We will be able to study not only the Boötes voids, but also thousands of other voids, compare their properties, and understand how they fit into the overall picture of cosmic evolution. There's also the idea of using voids as natural laboratories to test fundamental physical theories. For example, some theories suggest that the constants of nature, such as the speed of light or the force of gravity, can vary slightly depending on local conditions. Voids, with their extremely low density, can be ideal places to look for such variations. Boötes Void reminds us that the universe is full of contrasts. There are regions of incredible density, black holes, neutron stars, galactic nuclei, where matter is compressed to unimaginable values. And there are voids where there is almost no matter. These two extremes determine the range of conditions that exist in space. When you think about the fate of void Boötes on the scale of cosmological time, the picture becomes even more dramatic. In tens of billions of years, as dark energy continues to accelerate the expansion of the universe, the void will become even more isolated. The galaxies at its edges will move away so far that their light will no longer reach each other. Each galaxy will become an island in an ocean of expanding space, unable to see its neighbors. And those rare galaxies inside the void will find themselves in even more extreme isolation. If an advanced civilization exists in one of them, it may end up in an observable universe consisting only of their own galaxy. Everything else will go beyond the cosmological horizon, the boundary beyond which objects are moving away faster than the speed of light due to the expansion of space. They will look up at the sky and see only their own stars. For them, the rest of the universe will cease to exist. This raises a profound question about the nature of observability and existence. If something is beyond our cosmological horizon, does it exist for us in any meaningful sense? Voids in the distant future would be perfect examples of this problem. The galaxies within them would physically exist, but would be completely cut off from the rest of the universe. It is also interesting to think about the fact that the void of Boötes is a structure frozen at a certain point in cosmic evolution. The light we see from its borders shows us what the void looked like 700 million years ago. During this time, it has changed, grown, evolved. We never see the void as it is now, only as it was in the past. This is true for all astronomy. But for such huge structures, this time gap is particularly impressive. The Boötes Void may also hold clues to the earliest moments of the universe. Those tiny density fluctuations that were built into during inflation. The incredibly rapid expansion of the universe in the first fraction of a second after the Big Bang determined where galaxies would form and where there would be voids. By studying the modern distribution of voids and clusters, we can draw conclusions about the nature of these primordial fluctuations. Some cosmologists suggest that patterns in the distribution of voids may bear the imprint of the processes that took place in the first moments of the Big Bang. It's like the archaeology of time. We're digging up traces of events that took place nearly 14 billion years ago, studying the modern structure of the cosmos. The Void of Boötes is one of the pages in this ancient history. There are also suggestions about the existence of so-called mini-voids inside large voids, voids within voids. This is a hierarchical structure where the same pattern is repeated at different scales. The universe is fractal in a sense, at least on cosmological scales. If such mini-voids exist inside the Boötes Void, there are even more extreme examples of the cosmic void. For astrobiologists, voids present an interesting paradox. On the one hand, there are fewer galaxies, which means fewer stars and planets where life can originate. Galaxies and voids, on the other hand, are more insulated from catastrophic events, such as gamma-ray bursts from nearby galaxies or close passages of stars that can disrupt planetary systems. Perhaps life in voids is more stable, although more lonely. Imagine an advanced civilization in a galaxy inside the Void of Boötes that has achieved the ability to travel interstellarly. They can explore their own galaxy, visiting the billions of stars within it. But traveling to another galaxy would be incredibly difficult. The nearest neighboring galaxy could be tens of millions of light years away. Even at close to the speed of light, such a journey would take tens of millions of years. This makes intergalactic travel almost impossible for civilizations in voids. The Boötes Void can also affect the spread of life in the universe, if such a spread is possible at all. The theory of panspermia suggests that life can travel between planets and even between star systems on meteorites or comets. But voids create huge barriers to such spread. Life that originated in the galaxy inside the void will be permanently trapped there, unable to reach other galaxies naturally. From the point of view of information theory, voids can be considered as areas with minimal information. Information in the universe is mainly contained in the structure of matter, in the arrangement of atoms, in the configuration of stars and galaxies. There is very little matter in the voids, which means that there is less information there. These are the simplest, least complex areas of space. But this simplicity is deceptive. Even in voids, there are subtle gravitational fields, streams of dark matter, and passing photons from the cosmic microwave background. The void is not completely empty. It is just much more sparse than other areas. And this rarefaction has its own complexity, its own physics, its own mysteries. One of the most intriguing ideas associated with voids is the possibility of using them to detect gravitational waves. When massive objects like black holes merge, they create ripples in space-time, gravitational waves. These waves travel through the universe and can be detected by special detectors. Voids, being regions with low matter density, can serve as a kind of natural detectors of gravitational waves, since they have less noise from other gravitational sources. The Boötes Void is a reminder of how strange and wonderful our universe is. We used to think of the cosmos as a space filled with stars and galaxies, but the reality is that most of the universe is just such voids. 330 million light years of almost absolute nothing. This is not a mistake of nature, not an anomaly. It is a fundamental characteristic of the cosmos in which we live. Every time we point our telescopes toward the constellation Boötes and peer into this gigantic void, we learn a lesson in humility. We see that our place in the universe is a tiny island of matter in an infinite ocean of emptiness. And at the same time, we see the beauty of cosmic architecture, how gravity and time created this magnificent structure from filaments of galaxies and huge voids. The Boötes Void will continue to exist for billions of years, slowly expanding, becoming more and more empty. The galaxies at its boundaries will be moving away, and the few galaxies inside will become even more lonely. But for us watching it from our corner of the universe, it will forever remain one of the most fascinating and mysterious objects in space. It is a place where there is almost nothing, but where the answers to the most fundamental questions about the nature of reality are contained. How did the structure of the universe originate? What are dark matter and dark energy? How does space evolve? The Boötes Void helps us answer all these questions. And the next time you look at the night sky, remember that they're far beyond the visible stars, beyond the boundaries of our galaxy, in the direction of the constellation Boötes, there is a gigantic void. 330 million light years of absolute darkness and loneliness. Void Boötes awaits there, a silent witness to the majesty and emptiness of our wondrous universe. Thank you for being with us on the Cosmology channel. Like, subscribe, and see you on your next trips to the most mysterious corners of space.